All right, once again, this is your math teacher making a video over again that she already made. This is 8.1. I will label it as 8.1a when I save it. And on this one, I started out by saying this is a section that's got a lot of stuff in it that you don't really need to know. So if you watch the video, you'll know what's important. And when you do your homework, it's got 20 questions. If you can do 12 of the 20, I'll change your grade so that it looks like you did all 20 of the 20. I'll do that next week sometime. If you already did all 20 of the 20, congratulations. But no, I'm not going to give you extra credit for that. All right, so you need to do 12 of the 20 problems on this section. All right, so boy, I had my cursor right on that thing here. All right, so here's what this section's on. It's on basically some definitional things like parallel lines. Parallel lines are two lines in the same plane, meaning on the same surface, that never cross, or you may have learned it as two lines that are equal distance apart. Then they have some things with angles. And the things that you need to know about angles is that an acute angle is one that measures less than 90 degrees. And I can remember that because isn't it a cute little angle? An obtuse angle is one that measures more than 90 degrees. And a right triangle is one that forms exactly 90 degrees. Your most common thing that you see in your house would be right angles. The edge of a table, most commonly, unless it's an oval table, would be a right angle. The edge of a room would be a right angle. A door base would have a right angle. Okay, so it's a 90-degree angle. Your table's in our classroom. I'm sitting at one of those now, and it has a right angle. Then some other definitions is complementary angles. I for years have taught this and all thought it was spelled the same way as complement. It's actually complement. It's spelled a little bit differently. But there are two angles that add up to 90 degrees. So a 30-degree angle and a 60-degree angle, if you put them together, would form a 90-degree angle. So anytime two angles form a 90-degree angle, they would call complementary angles. And I can remember that because I think of when I compliment somebody, I said to my husband, "Oh, since I met you, my life feels so right." Get it? Right. My life feels so right that the two of us together complement each other, and so therefore we are right together, forming a right angle. Supplementary angles. Supplementary angles are two angles that form 180 degrees, which is also called a straight line. Okay, so that's a straight angle, 180-degree angle is called a straight angle. Okay, and two supplementary angles would add up to be 180 degrees. And I can think of that right now. Many of you probably can too, is with things going so crazy, you might need somebody to supplement your income so you can stay straight with your bills. Okay, so a supplementary angle would be one that would form a straight line. So the kinds of problems you might see on that is you might get a problem where you have a right angle shown, and then you have one angle shown to be 18 degrees, and they say, what is the measure of the other angle? So when it says M and then an angle symbol and 1, it's looking for the measurement of angle 1. Well, you know that the two angles add up to 90 degrees, so the missing angle must be 72 degrees. Likewise, if it forms a straight line, you get to some problems like this. It'll say, angle 2 is 3 times the size of angle x. How big is angle 2? Well, that one takes a little bit more algebra. You'll say, well, x is the first angle. The other angle is 3 times x, and together they form a straight line, so that's 180 degrees. So x plus 3x is 4x. And divide both sides by 4, and I get x is 45 degrees. So angle 1 is 45 degrees. So angle 2 is 3 times the 45 degrees, which is 135 degrees for angle 2. So be sure when you do that problem, I almost made a mistake the first time I did it. I said x is 45 degrees, which is correct. But if the question was, how big is angle 2, and you put in 45 degrees, you're going to get it wrong because angle 2 is 135 degrees. It's 3 times angle 1. Okay? Then they do a whole bunch of things with parallel lines. And so I drew a parallel line and I cut the parallel line. That's called a transversal, is a line that cuts parallel lines. And when I do that, it forms 8 angles. And those angles have certain characteristics. For instance, angle 2 and 3 will be equal. Those are called vertical angles. Vertical angles, here's an example of vertical angles. Vertical angles are 2 angles formed by lines crossing. So the vertical angles will always be equal. So that means angle 1 and 4 are also vertical angles, so they would have to be equal. So they are also equal. So they're basically just going, hey, when you cut parallel lines, you form basically a bunch of angles, but there's not that much difference in those angles. So I gave an example of that on the next page. I'm going to cover up my results here. I took a picture where I know one of the angles is 38 degrees, and that's the only thing I know, is that one angle is 38 degrees. So then I go, well, if I know that, so I wrote down my numbers, then angle 2 must also be 38 degrees because they are vertical angles. But if these form a straight line, then angle 1 must be 142 degrees. So angle 3 has to be 142 degrees. Then I went on and I said, well, they have this other term they called alternate interior angles. So angle 2 and angle 5 are what we call alternate interior angles. They are also equal. So if 2 is 38 degrees, then angle 5 is also 38 degrees. And once I know that, then angle 6 has to also be 38 degrees. And angle 7 has to be 142 degrees. And angle 4 would also be 142 degrees. So once I know one thing, I can find basically all of them. And that is the end of that section.